Okay, in part 2 of section 2.3, we're going to practice deductive reasoning, inductive reasoning, the law of detachment, and the law of syllogism. And so we have the guided practice to do that on the back side of your sheet, and I'd like you to go to page 88, and we'll do these together, sort of. You can pause to get to that page. I'm going to continue. All right. In number 1, you are given an angle R that is between 90 and 180. So if this measure of angle R is between 90 and 180, then it is obtuse. So here you have the angle R between those two measures. That makes it obtuse. That's our definition of obtuse. So that's a statement. And what follows the if is your hypothesis. What follows the then is your conclusion. Now you're starting with another statement. You're starting with it. It starts off saying the measure of angle R is 155 degrees. And our job is to make a conclusion from there. Now we are going to use the law of detachment when this situation occurs. What statement can you make? The law of detachment starts out with a statement like we have up above. You have an angle between 90 and 180, then it's obtuse, and then it starts the beginning of another statement. So it goes on to say the measure of angle R is 155 degrees. Well, then we can go on to conclude that angle R is an obtuse angle. So that would be using the law of detachment. You are going to finish the statement. Number 2, if Janelle gets a job, then she can afford a car. If Janelle can afford a car, then she will drive to school. Using the law of syllogism, what statement can you make? When you read this out loud, you actually hear yourself saying she can afford a car twice. That is your linker. You actually have P is implying Q. That's the if Janelle gets a job, then she can afford a car. Let me write that actually to the right of this. P implies Q. Then the next statement you have if Janelle can afford a car, so you're starting with Q, then she will drive to school. It's implying R. Now putting that together, what you have here is your linker. Use the law of syllogism. So the law of syllogism always has this linking action going on. So what statement can you make? You can make this statement. If Janelle gets a job, that's our P, then she will drive to school. So you need to make a conscious difference between these two types of logic. In the law of detachment, you are just making a conclusion. In the law of syllogism, you're setting up a new statement, and it is making a connection between all the statements given. P goes to Q, Q goes to R. Let's just consolidate it and cut to the chase. That's the law of syllogism. Alright, number 3. If you get an A or better on your math test, then you can go to the movies. Yeehaw! If you go to the movies, then you can watch your favorite actor. Well, now, you get an A on your math or better. If you get an A or better, boy, that's kind of hard to do. Anyway, if you get an A or better on your math test, then you can watch your favorite actor. Now what we did is we put the statement from above, we put it together, we condensed it, we cut to the chase, which law of logic is illustrated. And hopefully you're saying this to yourself. This is going to be your law of, and hopefully you're practicing this word, it's syllogism. And just for proper sake, I think I'm going to need to make this a B or better because it's a little hard to make an A or better. It would be an A plus, I guess. Alright, number 4. If x is greater than 12, then x plus 9 is greater than 20. You are given the value of x is 14. Therefore, it's going to have x plus 9 be greater than 20. What you started with was a statement, and what then was given to you was the first part, which satisfies the first part of your given statement. So if the hypothesis is true, then also your conclusion will be true. And which law of logic is illustrated here? Hopefully you're saying it to yourself again. This is going to be your law of detachment. Okay, law of detachment. The law of detachment works from one statement. And then when you bring up some information, if it fits that statement, then you can go on to make the conclusion. Number 5, use inductive reasoning to make a conjecture about the sum of a number and itself. Then use deductive reasoning to show the conjecture is true. So we're using inductive first, and we're going to make a conjecture about this idea, the sum of a number and itself. So I'm going to go ahead and set up some data. I'm going to observe what the statement is saying. A sum of a number and itself would be this, a sum of a number and itself. So 1 is the number, and then itself would be another 1, and you're adding them, you get 2. And then the number and itself would give me 4. A number and itself would give me 6. And one more, a number and itself would give me 8. So now I'm recognizing that there is a pattern. And so when I see this pattern, I'm going to come up with my conjecture. My conjecture, maybe you can see what's going on, if this is my number, when I add the sum of a number and itself, the answer is twice our number. So I'm going to say the sum of a number and itself equals twice the number. The sum of a number and itself is twice the number. Okay, I'm going to move over and work on this. I'm going to use deductive reasoning to show that my conjecture is true. So I've got to use facts now. Well, here's my number, the sum of the number and itself. So now I'm doing general terms. I can make, instead of 1 plus 1 being 2, I'm going to say an x plus an x, because x is representing any number. So I'm doing this as a general case. Now, by algebra, when you have like terms, you can collect like terms and you get 2x. So I'm using my rules of algebra. These are known facts. Now I'm going to state this again. The sum of a number and itself is twice the number. And voila, sure enough, you can see that it is 2 times the original number. Okay, let's go on to number 6. It says to give an example when you use deductive reasoning in everyday life. When you use or used. Let's see. What's been going on for you? You have to say, here's a deductive reasoning. You have P implying Q. We have to say 2 parts. So how about this? Whenever we have a geometry test, then we do not have homework that night. Then we do not have homework that night. Alright, so here's how our deductive reasoning is going to work. you are going to go on and say, we have homework tonight. So, we did not have a test today. That's our logic. And it's a deductive, or that's our reasoning, and that's deductive reasoning. So, we did not have a test today. Because we know from up above, whenever we have a test, we do not have homework that night. And that's P implies Q. What I wrote down below is I switched it around and I negated each part. So I have not Q because we have homework tonight, and that implies not P. So we did not have a test today. I should say have a geometry test today. Alright, that concludes the examples, and hopefully it makes sense to you for section 2.3, and good luck with your homework.